Okay, as promised, I am going to go through a few of these calculator applications that I have programmed or nicked or adjusted from the web, and then point you to the fact that you bought the things. It's probably a great idea. I've already seen a few people start to program them, and I'm going to point you to a couple things I'm going to hope and expect you do as you do your programs so that we can share them, get some credit amongst ourselves, but also put a little plausible deniability in there, because the ownership of the program is going to be tied to somebody, your super unit's name. Now that's just a device we're going to see here that's going to keep us consistent, so as we're passing calculator programs around that might do the same thing, we can eventually vote on which ones are going to be more useful or more correct, and keep that going. So I will point out that the download of the debugger, Flash Debugger, I highly recommend it, and also the TI Connect. And it turns out actually the TI Connect for Mac actually is much slicker, and I just noticed that yesterday. So I'm on a Windows here computer, and I have actually then gone and uploaded all my programs into this emulator, which means that I can now this should run exactly like it would on your calculator. So that's my hope. And so let's just double check. Let's see how I've loaded it. First off, in the programs, I've got to turn it on, which is kind of odd. In the programs, I've got all my programs there, and I'm going to hit second quit here. I'm going to check the mode. Degree is set. When you're doing these, it's pretty nice idea. Makes it easier to read if you just put float at 1 for now. Obviously, sometimes we'll be using parametric. Down here, simultaneous is going to be a nice thing to have set, but we've got that set. And I want to point out that because of my lackadaisical programming, you also need to have some matrices. I'm hitting second matrix there. The A needs to be a 3x7, the B a 3x7, the C a 2x3, the D a 2x3, the E a 3x4, the F a 3x3. Remember, matrices are lists of lists. The G a 3x1, the H a 3x1, the I a 3x3, the J a 3x3, and I guess that's all of them. Now, one can be much smarter about this than I have in the programming, and you might want to we might want to look to reprogramming these. So at every program, you're actually initializing these matrices using the dimension command, and then getting rid of them when you're done. But that said, these are all loaded up, and if I look now to second list, I've got a set of lists here. Obviously, the lists 1 through 6 are the easiest to get, so they're nice to use them if you're hand keying things. But particularly, we know that U, V, and W are reserved. The U is the first vector, and the V is the second vector in a cross product. W will be the what we use for the cross product where we store the vector. Remember, U dot V, if those are two vectors, is a scalar, but U cross V is a vector, so a vector has to be stored in a vector format. V1 is one of the vectors we're using for when we're doing coordinate transformations, when we are converting from polar coordinates to rectangular coordinates. And so you got to think a lot of things that are saved. So I'm going to hit second quit here. Hopefully this will all work. So menu U and menu 2 are the two programs for now I've got set up, and they call most of these other programs. So if I go to menu U, this is what we did a little bit in class. We have the vector program, which is probably one of the more significant. That's kind of the whole point of using these calculators, is that you can do some pretty high order stuff that you think you could only do in AutoCAD or Civil 3D, but you can do in other programs as well in this calculator. Coordinate convert is just that going back and forth between polar and rectangular coordinates. That should be somewhat second nature even without a calculator, and every now and then you should just think, how should you do it? If it's going to be the Z component or the K component, you just take the sine of the elevation angle times the magnitude of the vector and go from there. Bernoulli's equation we will be using, and that's going to be something that this is just going to be a way for us to program a base Bernoulli equation in. This is using when we're looking at how much energy loss is due to friction. Manning equation, transformation, it's not quite Correct. I point that out, and I've got a note in there as well, and then vertical curve. So I'm going to go ahead for now, just go back through that menu U, and you're going to go quit, I guess. Somehow I broke the calculator. So I can go back to program menu U, hit an enter here, and I'm going to go to 6. I can click in 6. I go to vertical curve calculator. This is just an example to look at this program to see how straightforward vertical curves can be. In this case, if you're giving yourself an input telling it that in fact the slope has to be, in this case, in decimal format, this is actually working with pure distance. So it's not using, for instance, 10 plus 0, 0 would be 10, 0, 0 in this program, not 10. So I'm going to go, there's the dog, there's the door. If we're going up at 0.02, hit an enter, going down at minus 0.02. The length in feet of 600 feet is the length of your curve. The vertical point of intersection station, let's say that was 1,000. And the VPI elevation is 100. And then let's say that you wanted to know the elevation of the curve at 1107.63. While you'd put something there at that odd station, who knows, but it could be important. And you see it comes up with this calculation. Now, that's that. Hopefully, most of the times when you're finished with that, you can hit clear. I don't know that it goes back. Should generally go back to the to the menu. I'm going to go back to program here, and I just want to point out finally in this video here, I want each of you as your program to come up with a superhero unit's name. I'm Captain Klein. I don't know. That's my my father-in-law passed away years ago, and so I don't know. Captain Klein works for me. It's my super unit's name. In other words, the programs that I will do from now on will be CK in front of them, and I expect each of you to do it. If you want participation points, we'll talk about why as we're adding things to these units, particularly these. Gotta hit that here. I don't want the new software. We're adding things to these units, to these more or less places to save stuff that we're supposed to know. We need to know that a pound has units of slugs feet per second squared. We need to know that a joule is a Newton meter and a Newton is a kilogram meter per second squared. These are things that within engineering we need to be able to build back some of everything back to the feet pound seconds units. And so we're going to go ahead and I'll just run the CK units right now. And you see all I've done is put in my first kind of connector, and that is that 1 kilogram is the same as 2.205. If you take the inverse of that, you get 453.6 grams equals 1 pound, and also 1 kilogram is 9.8 newtons. This, in effect, becomes kind of your single best conversion between newtons and pounds. This one down here, 9.8 meters per second squared is 32.2 feet per second squared, is your best conversion between distance at this point, even though we learned 25.4 millimeters equals 1 inch. And then we finally have a 7.48 gallons equals 1 cubic foot. Now, you can continue to fill this out, and I will give you credit, but as we build, as I ask you these questions on an exam, no black book, my expectation is eventually this needs to be put someplace that you do not need it. You need to know some of these things somewhat off the top of your head. This is akin in engineering to that 3 times 3 equals 9. And I'm going to stop here and see how this goes and put out a couple more videos and go through the rest of the programs. Again, I recommend you download the debugger, Flash Debugger from TI site and the TI Connect. It will make things much easier for you if you can maintain and control your own calculator and not fear it all getting erased as you get a little bit used to using it.